All right, today is section 7.1, and we are going to look at decimals for the first time. So this is called Introduction to Finite Decimals. And when they say finite, they mean non-repeating, okay? So they stop. Finite is, and they conclude, they end. So to start with, the word decimal. The word decimal comes from the Latin word meaning 10. And there's some language associated with decimals that I want to familiarize you with. I know you've seen them before, but maybe it's been a while because we like to use the word point. When we see a decimal point in the middle of a problem, we say like 42.37. We do that a lot, right? Nod your head because I do it too. I know we do. And so we sometimes lose the language that is really associated with it. So let's use these two place values and then a decimal point. So if you were doing these, this would be the tens place and the ones place, sometimes called the units place, right? So we're going to do several place values after the decimal point and see if you can remember what they're actually called. So what is the decimal point after the, what is the place value after the decimal point called?
Tenths.
It's the tenths, yeah. So this is the tenths. There's going to be THS's on the end of all these words, okay, tenths. What comes after that? Hundredths. Thousandths. So you know what comes after the thousandths? Yep, you guys got this down. What would be next? 100,000ths first. We'll do one more. Okay, that was not small enough. Okay, and then Matthew, heard you say the last one. What was the next one I'm going to do?
I said 100,000.
Oh, I thought it was over here though. Nope. Somebody, millionths is next. I thought I heard somebody say, maybe I didn't. Yeah, millionths is next. And after millions, we'd have 10 millionths, 100 millionths. And then we'd have billions, 10 billions, 100 billions. We're not going to get that big, but that's how it actually would work if we continued on down the line. So what we're going to practice a little bit of, both now and then in your homework group work, is taking a number and not saying 34 and 34.4236. We're going to say it as it actually should be said. So the first part we do really well. We always do. We say 32, right? That's no problem. So 32 actually has a hyphen between the 30 and the 2, if you weren't remembering that part. The decimal point is the word and I have very, very specific memories from second grade, being in trouble with my teacher all the time because I wanted to use the word and in the middle of things that weren't decimal points, like 342. And I remember her saying, we don't use the word and there, we don't use the word and there. So the and represents the decimal point, okay? What we do next is we read this number, the last 4 digits here, as though it doesn't have the decimal point value. So just ignore the fact that tenths and hundredths and all that kind of stuff. Just look at what's there. How would I write the number if it were 236? Yep, and that's what we're going to do. We have 4,236. And again, the 30 dash, the hyphen 6. And then we identify the place value where that last digit falls. So what place value am I in on the 6 in this number? It is the 10,000ths place. So we write the word 10,000ths at the end of this. So this is 32 and 4,236 10,000ths. That's how we read it. Okay? So we're going to go the other direction. We're going to take the language of 1 and rewrite it as the numerical form in example 2. So the language form of this says 536 and 76 thousandths. So let's start with the value before the and. It says 536, so what am I going to write down? Yeah, 536. And the and means a decimal point, right? Okay, so this number 76 is, of course, written as 76. But where does the 6 have to end? In the thousandths place. So how many decimal points should I end up with? 3. So if I'm supposed to have 3 decimal points, but it's supposed to be 76, and the 6 is supposed to be in the third spot, what am I actually going to write?
0.
Yeah, 076. So be careful, that will happen, right? Where the decimal point doesn't end just 2 places later because there's 2 digits that you're writing down and you hear both of them. We don't hear the 0, right? It's there, we just don't hear it. So this is actually what this would look like. Obviously it looks a little weird, but if I write it out, that looks better. Okay? Any questions on that? All right, when we do number theory, we talk about the fact that we work in base 10. There's other bases that are around. Those of you who've done number theory before know I'm talking about specifically, and maybe others of you have seen it in another class recently. But we talk about the fact that all of our place values are base 10 values. So like if we have our ones place, 1 is really the same as 10 to the 0. And if we have the tens place, that's 10 to the 1. And if we have the hundreds place, that's 10 squared. And they're all base 10 numerals. And it works the same way when we're working with decimal points. So if I have the 3 decimals that I just wrote down, this is the hundreds place, the tens place, the ones place, but we understand that this is 10 squared, 10 to the first, 10 to the 0. The decimal point doesn't change any of that. They're still base 10s, and I'll write just 3 of them after this. We said that this is the tenths place, but that means it's 1/10. This is the hundredths place, which means it's 1/100th. And this is the thousandths place, which means it's 1/1000th. So we're going to be writing some things in expanded form. My preference is that you use the fractional versions of these, 1/10th, 100th, 1/1000th, because it's really obvious in terms of the language we use what we're talking about. If you choose, though, you may use the negative decimal or negative exponents like your book does. It's okay. I just feel like it gets hidden in what's going on. So this is 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. When I see this, I know that this is 1/1000th. When I see this, it takes me a lot longer to think about what that value actually represents. So that's my preference, is that you use the fractional notation, but either one's okay. So let me show you what I'm talking about on example 3. We've got the number 103 and 300ths, right? And it wants us to write it in expanded form. So expanded form means writing each digit times the place value that it's in. So like the 1 at the beginning is in the hundredths place. You can write or not write the 0. I'm going to write it just so it's there. The 0 is in the tens place. And then there's a 3 in the ones place. There's a 0 in the tenths or 1/10th place. And then there's a 3 in the hundredths place. That's expanded form, where it identifies which place value it's in by separating each of our numerals with addition and subtraction multiplied by the base of the place value they're actually in. Okay? The place value they're actually in. When we worked inside of fractions, one of the things that we talked about is being able to take a area diagram. Most of the time we used rectangles, although I know that some of you drew some circles based on some of the problems that you did on your test. But most of us did them with rectangles when you did your area diagrams. And rectangles work really, really nicely for looking at decimals. So if you take a large square, because you're going to need to divvy it up quite a bit, and you divide it into a 10 by 10, so you've got 10 rows and 10 columns. So we're going to see how well I can do with divvying mine up just like you are. It's certainly not perfect. That's 10 columns. I'm going to do the same thing on my rows. Something like that. This would be a 10 by 10 square grid, and it would contain 100 squares, obviously. And you can use this to actually draw a grid for a numeral, okay? So if you want to, I'm going to copy paste mine because I can since I'm working up here. But if you draw that same grid or a similar one on your next page, we're going to shade it in, draw it in for the numeral 24 hundredths. So I've got 100 small little squares here. What would I do to represent the number 24 hundredths? Yeah, I'd shade in 24 squares. And while it doesn't really matter where you shade them in, make it easy on everybody, all right? And do it in nice columns, right? So there's 20 on mine. And then I've got my 4 more. Don't make anybody have to count it because you zigzagged them or something, please. That's just not helpful. All right, so here's 24 hundredths in terms of a visual diagram. Okay, now as you're aware, some of the fractions that we work with are very nicely displayed in decimal form, and some of them are not. Can you give me an example of a fraction that's really easy to turn into a decimal? Anything. Some fraction's easy to turn into a decimal. 1/2, 1/4. Both of those would work. Easy to turn into a decimal form. What's a fraction that is not easily turned into a decimal form or turned into a nice decimal form? 21 over 52. It might, because it's going to maybe reduce. Hard to say, but I think you're right. A smaller one that you know for sure. 1/3 would be a really good example. Not easy to turn into a decimal form because it has repeats, right? And I think yours will as well, actually, Beth Ann. But yeah, there's certain fractions that change into decimals nicely, and there's others that don't. And there's actually a reason for when they do and don't have that property. So a rational number, a over b, in simplest form can be written as a terminating decimal. Those are those nice ones we just talked about. If and only if the prime factorization of the denominator contains only 2's and 5's. So Danielle said the number 1/2, right? The number 1/2 contains a denominator that's only 2's. We said the number 1/4. When I factor out the 4 in the denominator, it's 2 times 2. And nobody said 1/5, but it would work as well. If I did 1/5, it will very nicely have a 5 only in the denominator, and it will also change into a very nice decimal. So Brooke said the number 1/3. 1/3 has a 3 in the denominator. There's no way to simplify that into a nice fractional form because it's a 3 that's in the denominator. So we're looking for things, or we're identifying fractions as being easily turned into decimals or into terminating decimals based on what their denominator is. But notice it says in simplest form. So for example, you guys gave me the number 1/2, which is lovely. But if I took 3 over 6 and I said, hey, look, 6 is 3 times 2, so it's not going to be a very nice fraction, you forgot the simplest form part of it. You have to reduce the fraction first before you can decide, does it have a terminating decimal form? That's the difference, okay? Got to be in reduced or simplified form. So we're going to take a look at some examples, and it says to mentally determine if the value represents a terminating decimal. If so, write it as a terminating decimal. So what is it actually saying? Well, it's actually saying the goal is not to start out by trying to figure out if it is by dividing. It's going to decide, is it going to be by simplifying first and then factoring denominators? So looking at this one, 9 over 24, is it in simplified form? No. So factoring the numerator and the denominator would be a good first step. So 9 is 3 times 3, so that works well. What about 24? What is it? Okay, so it's 3 times 8, and then 8 is 2 to the third, right? So you've got 3 times 2 times 2 times 2. And what do we notice? Yeah, they have a matching 3 on top and bottom, so that reduces. I still have a 3 on top. You can write this as 8 if you wish on bottom, or you can write it as 2 times 2 times 2 on bottom. It won't matter. But the question is, will it be a terminating decimal now? It will. And the reason it will is because the denominator has only factors of 2's or 5's. In this case, 2's only, but that's fine. So it is a terminating decimal. So it said, if in fact I have a terminating decimal, what am I going to do? Write it as a terminating decimal, which means to do the division to see what that would be. So the denominator is what you're dividing by, 8. The numerator, 3. And I'm going to need decimal points to make this work. I don't know how many. I think that's enough, actually. All right, so clearly 8 does not go into 3, but 8 would go into 30. How many times? 3. So here's my decimal point straight up. I've got a 3 here. We'll talk more about division of these later, but 3 times 8 would be 24. Subtracting gives me 6, and I'll bring down a 0. So 8 goes into 60 how many times? 7. What's 7 times 8? 56, good. And I subtract, I get 4, and bring down my 0. 8 goes into 40 how many times? 5, and 5 times 8 is 40. So I subtract, nothing left. The decimal that I'm looking for is right here, 0.375, or 375 thousandths. Okay, let's try part B, 10 over 24. Is it reduced? No. So how will it factor? And I already did 24, right? It's 3 times 2 times 2 times 2. So if I simplify, what will simplify? Get rid of one of the 2's. Yeah. So a 5 on top. If you wish, you can multiply these back out, or you could leave it as 2 times 2 times 3. Will this be a terminating decimal? No. What's causing problems on this one? The 3. This number right here in the reduced form, still being in the denominator, means I will not have a terminating decimal. And when we get to section 7.3, we will talk about those repeating decimal problems, but that's not what we're doing today, okay? It's often helpful to decide which numbers are larger or smaller, depending on what you're doing with them. You may wish to have one value or another. If you were looking at interest rates for a loan or for a savings account, if you were looking at dollar amounts, right, it would be good to know which one's more or less. So we're going to talk about ordering or comparing decimals. So when we're looking at ordering and comparing decimals, we're going to line the numbers up by place value, which really means with the decimal point, right? The decimal points are our guideline. We read the numbers from left to right to find the first difference, the place where they are different, and then we compare the different digits. Now, I think that it's a lot easier to compare the numbers when they're written vertically on top of one another. So when you look at these numbers right here, I think it's tricky to always get them in the right order when they're written in this sort of line format, like horizontally side by side. But if we write them one on top of the other, I think it becomes a lot easier to do it, and you'll be a lot more accurate at doing so. So there's the first one. Here's our second one. The third one. and the fourth one. And the directions say least to greatest. Whenever I have students in an online class, even in this class like this in person, but especially for some reason in an online class, the least to greatest and greatest to least often goes backwards. There's just this sort of a, whichever one you're used to doing, you tend to do that one first, you know, and it may or may not be the one that's, so be careful. Look at the directions. Does it say least to greatest or does it say greatest to least? This one says least to greatest. So if I'm following sort of that list of guidelines on the previous slide, it told me I'm supposed to look for the place where they are first different. I have a typo, don't I? That's supposed to be a 3. Okay. So before the decimal point, they do match. They're all 4 13s, correct? And the first decimal point in the 10th place, those also all match. And then the next decimal place, the 9, and the 100th place, those all match. So the first place when they're actually different is the 1000th place, the third decimal place before any of them actually are different. Which one is different? The second one. And this number is a 2, which is larger than the ones. Agreed? So does this make this one the largest value or the smallest value among the 4 numbers? It's the largest because it's bigger than the ones. So this is my largest value. So in terms of numbering them from smallest to largest, it's going to be the biggest number, right? It's going to be sort of number 4 in my list. And so I can ignore it now. I don't need to look at it anymore. I already know where it's going to fall. So I'm moving on to the 10,000th place where I have a 9, an 8, and a 9. The one that's different, of course, is the 8. So what does that tell you about that number? It's the smallest. This would be the smallest. So again, if I were numbering them from smallest to largest, smallest would be the first in my list of numbers. All right, so the last one to compare are the first one in this case and the last one. And they match clear until there's a 9, and then there doesn't appear to be anything here, right? So what is there an understood value there that, what is their value that's understood to be there? It's a 0. So if it helps you to write it in to do the comparison, by all means, write it in and make them the same, number of digits as you do the comparison. So looking at that 0 on the first number and the 9 on the last number, what can you decide? Good. This one would be my second smallest, which makes it, sort of like the second number 2. And then the last one here would be my second largest, which would be the third number. Okay? So you're going to have to write something down for me to know that you're making these judgment calls when you're working through the numbers. Doesn't necessarily have to look like mine, but something that helps me see how you're deciding. And then you're going to write them in order from least to greatest. So the smallest one was 13. And then I have 49183. You can put a comma, or if you want to use a less than symbol like that, that's what I'm going to use. Your second smallest, which is the top number, was 13, and then 4919. The next one is the bottom number, 13, and 49199. And then our largest number is 13 and 492. So this would be our ordering from least to greatest. All right, last question for us to look at together today. What is the meaning of the word tithe? So most of you are probably familiar with the evangelical church setting and have heard this word tithe before. What is the meaning of the word tithe? What did you say? Giving 10%. Did most of you think percent? So we often think of this word tithe as being 10%, write this. And 10% is the same as 1/10. Okay, so these are all equal ways of describing the same thing, different forms of the number. And it's 1/10 of something. So when we talk about tithing our income, our increase, as the Bible would describe it, we're talking about our income, right? What we make in whatever job setting that we're in, okay? So we're talking about 1/10 of our income. But if you actually look back at Old Testament stuff, they would do other things too in the Old Testament that are very interesting. They would tithe 1/10 of their spices. Can you imagine going into your mom's or your dad's or your home and you see where the spices are and like weighing out 1/10 of the, cumin or whatever? Like that sounds just so different to me. That's not how we think of the word tithe, but that was how that they did that, back in the Old Testament. So it's not always 1/10 of money. It doesn't have to be that way. There are people too who will talk about tithing or giving 1/10 of their time. What are they using, their time for? How are they focusing their time in a given day or in a given week? How do you give 1/10 of your time? So it's not always money. That's what I want to describe first, not always money. So how is it related to decimals? Well, I've drawn sort of these 4 different ways of describing them, and of course we see a decimal representation for one of those, right? So in practice, when we talk about tithe, one-tenth of our income. So, for example, when I'll say when I pay my daughter $20 for babysitting and doing my other daughter's hair. That's what usually that works, because it really takes a long time to do little black girl's hair. Do you guys know that? It's time consuming, and one of my daughters is just super good at it, so I let her. It's 'cause she's going to do it so much faster, so I'll pay her to do that. So if she gets $20 for doing that, how much is she going to pay for her tithe? What would that be referring to? 0.2%. Okay, but of $20, like how much money would it be? $2. So if she earns $20, she will give $2. And in our house, we tend to round up. So if she had earned $25, she actually would give $3, because I don't think coins are necessary when we're worrying about that. That's not the motive behind the principle at all. So anyway, that's how we can actually relate our idea, because we do it with our income, to the decimal values themselves.